Okay, good morning, everyone. Just want to give you some current updates, the research that we're working on, and Rich already gave us some of a lot of information on those fertilizer guidelines that we have. For this presentation, you'll expect to get some information of the nitrogen study that we're conducting mainly on the use of remote sensing and variable rate technology system. I'll give about a couple of slides talking about the nitrogen source and some of the trials that we work on sulfur study as well. So you've seen these slides already, in Rich, showing the current recommendation we have for nitrogen fertilizer, where we refine the recommendation based on crop age and textures, giving all these rates that we have here, 60 to 80 pounds, up to 100 to 120 pounds on heavy soils on a stubble cane. So what's quite outstanding here is that the fertilizer recommendation is given and is applied uniformly in the field regardless of condition. And that's where we come in with the use of variable rate technology in the system. So every field is different. I have a few slides demonstrating this. This is an image I got from Google Maps showing those areas in the field of sugarcane that are not quite, I would say, not a healthy stance, and pretty much they receive the same amount of nitrogen fertilizer as the rest of the field. And so these are also, again, example of the within field variability, where you see those stands of cane that are quite outstandingly not as vigorous as the rest of the fields that perhaps receive the same amount of nitrogen fertilizer. This is one side that we have with Kate Dugas, where you see this field here. We got it from Google, and there's two types of soil in here. One on a commercial loam, and a small portion on the west part of this field is that quite silty clay. It looks uniform. Um, but when you look at the crop, again, an image to take from Google, you see those variability that exists within the field. So just, ignore this part here because they were taken as a seeding source. But the rest of the field pretty much shows that they're not equally as healthy as the rest of the part of the field. Year-to-year variability, I think I've shown this slide so many times, demonstrating the variation that exists within time. So this is the optimal rates of nitrogen that we got from different variety and different years. This is way back in 2004. The rate of nitrogen fertilizer that maximize yield can range between 40 to 120, and those you can see those years that is different. And for plant cane, we have cases that we did not get any response, also meaning that the application of nitrogen fertilizer did not result to an improving yield. And so that's something quite to think about, that year-to-year variability also exists. And even so, we come up to a point that we apply the same rate of nitrogen fertilizer in the form of 80 pounds of nitrogen per acre. So we have here data showing different sites in St. Gabriel and Iberia, different years and crop age. So those red bars receive 80 pounds of nitrogen as opposed to the blue bar, which is the check. And so those number on top of each of those bars represent the increase in tonnage due to nitrogen application. So you can see that differences in benefits in terms of cane tonnage increases, applying the same rate of nitrogen fertilizer, simply demonstrating the differences in nitrogen requirement year after year and also within the field. So we come up with some sort of a way of improving our nitrogen fertilizer management. We will develop a better decision tool. That was a goal many years back, and we're so glad that we're able to put out now this applicator that allows us to do a better application method for nitrogen fertilizer, where we apply nitrogen on a need basis. We have to tie it or use what we call this optical remote sensing technology that allow us to do a real-time, fast, and instant monitoring. Therefore, a recommendation will come out to in seconds. And we also paired this with variable rate application system, allowing us to variably apply nitrogen fertilizer based on the recommendation that will come out from the remote sensor data that we collect on the go. So we have this applicator system running now in the field, equipped with 2 sensors that takes up reading on the go. We have a computer that saves those data, process them, and pass down the information to the system that allows to variably apply nitrogen fertilizer using a flow meter and a control bulb. And we have that drop nozzles that dispense the nitrogen fertilizer based on what was the recommendation on about this is done on the go. The process is quite quick, and you can see here the diagram on the picture on the left showing a sensor on top of the canopy of cane, and as you move forward, that sensor picks up the reading. About two feet away behind it would be the drop nozzles, and you can see that it's just dispensed. The nitrogen fertilizer depends on what the recommendation after the processing of data going through the computer and convert it into nitrogen fertilizer and dispense that information, controlling the flow rate, and finally get the fertilizer out on a need basis. So with this technology, we have to pair it up with what we call these enriched strips, which is giving us a reference whether we get a response to nitrogen fertilizer. And if we do have response for this particular year or certain years, then how much is that? It's going to be some sort of a basis. We do encourage that the process by which you can use the enriched strip is that you have to establish 3 to 4 years 4 weeks before putting out the nitrogen fertilizer. So this is something that you have to do in advance so as to get the reference out before your scheduled fertilizer application. So a picture here showing the nitrogen strip, enriched strip in 2018, where Kate is standing beside it. It's quite showing, and this one in 2019 as well. So once you see the nitrogen strip being greener than the rest of the field, that's an indicator that there would be a benefit coming out from nitrogen fertilizer. How much and where we should apply it, it is the variable rate technology with the remote sensing will do the job for us. So I have here the sugar mother farm where we use, this is about 65 acres, where we put out the enriched strips. So the enriched strip can be put out based on the number of, based on variety that you use, and you have the crop age being another category that you can make decision on how much nitrogen strip you will put out. So here in the sugar model farm where we have about 1, 2, 3, 4, 5, 6 enriched strip, because we have we have a couple of variety, 299 and 540. 1 stands for first ratoon, 2 stands for second ratoon, P stands for plant cane. So we come up with this reference to make sure we have a representation for this different cultivars and crop age. So once we had that enriched strip put out, we got this. Kituga simply text me out the information. So here, this upper portion here, we have the reference strip that gives you the max, the average, and the minimum reading. And we have here the non-reference, which is a representative of the rest of the field that will be applied for that particular day. So you can see we're seeing the average reading 0.44 versus, excuse me, the average reading of the non-rich of the rest of the field that will be applied with nitrogen, and the highest reading of the reference strip, which is 0.54. With that, I run it to the algorithm, and this is what I am giving to Keith Dugas, and he will punch in this number where we have different ranges of NDVI reading and the corresponding rate that needs to be applied once those readings fall between those ranges. So that's the nitrogen rate. So we have 6, like I said, this is the Taylor Foundation project. We have 6 reference strips, and we have 6 that came out last year. And last year also Keith Dugas utilizes almost 50 nitrogen-rich strip, as shown here. NS stands for nitrogen-rich strip. So he used up 49 of them. So every time he has the nitrogen-rich strip, this recommendation will come up, different ranges with the particular recommendation of nitrogen fertilizer that he needs to apply using this applicator. So I'm going to play a short video clip showing this computer showing how the fertilizer is being applied. You can see this is the applied in gallon that changes as the machine runs through the field. And so as it does that, there are two sensor picking up readings on the two outer rows, averaging them into two and get the recommendation out. So the working resolution would be 3 rows here. So those sensor reading pick up those canopy or NDVI reading, averages them from the three, and then concurrently applying nitrogen fertilizer. So with that, you'll see, go back to the screen. As you finish up the field, we will be able to map both the NDVI reading and the nitrogen that is applied to the field. And so I have an example after this. So you can see as at its drive, it's actually giving out how much nitrogen is being dispensed on a given working resolution. So an example of the map is like this. So like I said, you can collect the NDVI and what is currently applied. So this is the NDVI map that you can get after you apply the fertilizer. You can download this, and this is giving us the reading of the NDVI per a section of the field, and also what is applied on those areas of the field where the NDVI were taken. So on average for this particular area, we applied 85 pounds per acre. So what we did, going back to that sugar model farm where we have this different enriched strip, we got the average of the nitrogen fertilizer applied. So imagine this is just an average, but the rest of the field received different rates. It could range from 40 up to 100 plus pounds of nitrogen per acre, but these are all averages from all over the amount of nitrogen that dispensed by the variable rate technology, and these are readings. So looking at the yield with all this applied nitrogen fertilizer, we have a 38.2 tons per acre average yield, which is quite just a little higher than the farmer standard practice of 120 pounds per acre. The TRS, that's where we have higher reading, about 276 pounds per ton. And then with that, we were able to get a sugar yield of 10,500 plus compared to 10,000 of the farmer standard nitrogen practice. So it's about 500 pounds more of sugar yield, and on average applied about 100 pounds of nitrogen, which is quite lower than the typical 120 uniformly applied recommendation. So it gives us an opportunity for us to look into an alternative ways of making use of nitrogen fertilizer more efficiently. So another thing that we're working on is looking at different nitrogen sources, and this is what we got from last year. We have what we see in this graph is the cane tonnage on the left graph here, and the sugar yield, and on the x-axis you show those differences, different sources that we have. We have the UAN, typical source of nitrogen fertilizer in Louisiana sugarcane production. We have UAN as well, urea, UAN with foliar application, and we have urea, strictly a nitrate source and ammonium source of nitrogen fertilizer. Keep in mind that both nitrate and ammonium are both forms of nitrogen that taken up by plant or sugarcane for this matter. So you can see the check, the application of fertilizer, nitrogen fertilizer at 80 pounds per acre, increase on average 14% increase in yield, both in cane tonnage and sugar yield. And you can see some of the potential, for example, ammonium sulfate giving the highest increase in cane tonnage of 7.2 tons per acre, with a maximum increase in sugar production of 1,847 pounds per acre compared to the check. So with that alone, picking the right source definitely has the potential to further increase benefits from nitrogen fertilizer applications. So this is something that we want to look into the future, combining with, on a need basis application of nitrogen fertilizer. These, though, are uncommon sources of nitrogen fertilizer in Louisiana sugarcane production, but this is something that we have documented and potentially could be a source down the road. So Rich mentioned about sulfur fertilizer, guys. We do have some tests going on also on sulfur, just to get some updates as well, or reminders on what we currently use on soil test for sulfur. We use the mandatory extraction procedure, and some of the projects that I'm working on is looking in other soil tests that possibly give us a better perspective of the sulfur capacity, supplying capacity of the soil. We might include organic matter and texture as well. So the current critical level for soil sulfur is 10 ppm. So any time that the soil test sulfur falls below the 10 ppm, we will apply 24 pounds of sulfur per acre. This is based on 30 to 40 years old research. There's also high probability of obtaining responses to sulfur fertilization when you're dealing with a very coarse texture soil. If the soil has low organic matter, and if the region has this high average rainfall, which is Louisiana is, which is actually allowing high leaching of sulfate, which is a very mobile nutrient in the soil. So it's behaving like nitrogen, and we lost a lot of sulfur in the form of sulfate leaching whenever we have substantial amount of rain. And this further aggravates or complicated by the reduced amount or reduced concentration of sulfate in precipitation comparing from 1986 to 2012. So that is a large reduction in the concentration of sulfate that we receive from rainfall, and that definitely caused a reduction in amount of sulfur that we get, free sulfur, if you will. So we particularly observe the reduction of soil test sulfur in St. Gabriel. Year after year, we put out multiple trials, and we do a lot of soil tests on that, including sulfur. In the past 5 years, on average, we conducted about 10 trials a year. And so whenever we pull out those soil samples, we did some analysis, and we graphed this, with time from 2009. And the recent one is 2020, this red dot here. So its level now is 6.8 ppm of soil sulfur based on medic 3 extraction procedure. And so this red line is just indicating this is the critical level. So this place alone at the research station, we're pretty much falling below the critical level of sulfur. Although granted that this might change because we're not still done for the rest of the trials that we put out last year, but this is what we got so far. But still, this is quite low now compared from what we started more than 10 years ago. So that indicates us really the importance of considering sulfur in your fertilization program. A few trials that we conducted, we had 3 locations as a single where we look into different sources, but comparing just the rates in one site between zero, a check, and with the 40 pounds of sulfur per acre against 25 pounds and another 40 pounds with different crop age of variety L0299. We see positive increase in cane tonnage up to 3.4 tons with the application, even at 25 pounds of sulfur per acre. That translates with an increase in sugar content. Now, what you see here, we monitor the leaf sulfur content 3 weeks, 6 weeks, and at harvest. This is 3 weeks and 6 weeks after we apply the sulfur fertilizer, and at harvest, you can see how it maintains a higher level of sulfur in the plant materials, specifically the leaves. And we also observe an increase in sulfur content in the shredded stalk samples that we analyze, and that those positive numbers all over the place just indicates the value of applying sulfur, and that translates to improved cane tonnage and sugar yield. Not surprised with the soil sulfur level, very minimal increase in the soil sulfur level, and I can see that because of this mobile nature of sulfate. So we might not have a complete picture, because whenever we test the soil, that is a snapshot information of the soil sulfate. It may change drastically depending on the rainfall condition. Among the sources that we tested, best performing sources, we use thiosulfate, which is the common one that we use in our production system. There are sources that are quite promising. MST stands for this. It's a sulfur, the elemental sulfur source, but this is in micro size. It's used as a coated material in muriate of potash, MOP. and as a liquid source as well that we apply or mix with UAN. So both of these sources are promising and perform, in fact, much better than thiosulfate, but these are the sources that potentially stood out when you're looking at across this trials that we conducted. So this is all I got of those current study that we conducted to supplement what Rich has just provided. And so I'll thank everyone for the opportunity to give me this time to share to you our research. And if there's any question, we'll be happy to answer that.